So when we're talking about four-sided polygons, guys, polygons can look like, if we're talking about quadrilaterals, there's lots of different quadrilaterals we could have out there. Let me just draw one here. It's just there's a lot of rando quadrilaterals that are kind of, there's not much we can do with them. So if you have something like, I don't know, if you just have something like this, 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 maybe this, something like this. Oh, sorry. Yeah, I got to unfreeze. Sorry. All right. There you go. So I don't know. Let me undo that just because it's just okay. So let me do an ink to shape. Maybe it'll give me something that. Okay, that's just a nothing. You guys understand that? This is a quadrilateral that's just a nothing. It just has four sides, straight sides, but it doesn't. We can't really do any work with this kind of quadrilateral. Like another one is like. Let me just see if I can do something like this. This is a concave, and it won't even do that. So just something like this. These are all just, I mean, these are great. They're quadrilaterals, they're four-sided, but they don't really do anything for us, guys. So the first quadrilateral that we always study is the good old-fashioned parallelogram. And so I want you guys to put this in your notes. Okay, a parallelogram. Okay, a parallelogram is a quadrilateral with both pairs of opposite sides parallel. That's the definition of a parallelogram. This is the definition. So I want you guys to get this copied down into your notes. This is the definition of a. Now, I like to say this is their symbol for parallelogram. This is what I like to call parallelogram. I kind of made this up myself. Parallelogram. That's how I abbreviate it. This is a Roden thing. No one's going to abbreviate it like this, I don't think. But that's what I just use the parallel sign, parallelogram. So I even get rid of the O. So this is a Roden thing. This is how I like to do parallelograms because I just hate writing the word parallelogram because I can never remember how many R's and L's and E's and L's and all that stuff I need, right? So, okay. So a parallelogram is, at minimum, is a quadrilateral with opposite sides parallel, okay? And nothing else. So if now we're going to get a lot of other good information here. So I'll let you guys copy this down. How long do we think we need to copy this down? A minute. Okay, let's get a copy down. Does everyone understand what a parallelogram is? I also call it sometimes a parallelogram that's nothing else. Okay, Mr. Roden sometimes calls these slanty boxes. Slanty boxes, yep. So a slanty box, Mr. Roden calls a parallelogram that's not a square, a rectangle, or a kite, not a kite, but a rhombus. If it's just a good old-fashioned parallelogram, I give it a name. I call it a slanty box. Okay, so yeah, not very good, but it's kind of what it is. It's a box that's slanty, right? You guys see that?
Doesn't have to be slanty though. Aren't squares parallel?
Yes, but that would make, so there could be squares, there could be rectangles, there could be rhombi, but all of those are special kinds of parallelograms. This, when we're talking about just a basic parallelogram that it's not anything else, I like to call them slanty boxes. Okay, not really a word, but okay. Guys, good with that? Okay, so I'll give you another minute here and we'll keep going here. Okay, so the next thing we want to talk about is we actually can say some really good information about a parallelogram. So if you have a parallelogram and you know that its opposite sides are parallel, you also know its opposite sides are congruent. It's a theorem. It's a provable theorem. So if it is a parallelogram and the opposite sides are parallel, that would be in our hypothesis, then we know that the opposite sides are congruent also. And that is actually a provable fact. And in a minute, we're going to prove why a slanty box has opposite sides congruent. Because that's not the definition of a parallelogram. The definition of a parallelogram is opposite sides parallel. But we can now say the opposite sides are congruent. And guess how we're going to prove that, ladies and gentlemen? Definitely going to use math. We're going to use congruent triangles. Very good.
Oh no.
So yeah, congruent triangles are back. Aren't we happy with that?
Yeah.
So let me do an ink to shape here. See if I can draw a slanty box. Let's see here. Let me do this color. So let's say we have the good old-fashioned slanty box. See if it'll give it to me. Awesome. So we have a slanty box. So we're going to call this parallelogram A, B, C, D. Okay? Now, we're only going to do one pair of sides at a time. To find the other pair of sides, you just repeat the process. You just use the other diagonals while you do. Sound good? So here's what's going to happen. So the given here is given A, B, C, D is a parallelogram. So we're just going to do one pair of opposite sides, but the same process will be the other side also. You guys understand that? We're going to prove, in this case, we'll just prove AB is congruent to DC. Okay? You guys with me on that so far? Sorry, all right. Now, how do we do that? Well, very simply, ladies and gentlemen, we are going to make a statement, reason, proof. Okay? So the first thing we are going to do is we are going to say in our given that ABCD is a parallelogram. ABCD is a parallelogram. Okay, see that? And that is a given. See that? Now, if ABCD is a parallelogram, then I can now say that side AB is parallel to side DC. Why can I say that, ladies and gentlemen? Ben, why can I say that?
Because the definition of a parallelogram.
It's the definition of a parallelogram. This is how I write the word definition. This is actually standard. DEF with a little N up. Do you guys know that's definition? That's shorthand for definition. DEF with a little def to the power of N means definition. I don't know. So this is the definition of a parallelogram. Okay, so I'm going to mark my picture because it's a parallelogram. I'm going to do it in red here. We can say that the opposite sides are parallel. Now, we could also do the other sides, but I'm really only focusing on these two sides. Okay, see that? Are there any questions so far? Okay, so the next thing I want to do, ladies and gentlemen, is I want to construct, I just want to make diagonal AC. Now, guys, do we all agree if you have 2 points, you can always you can always construct a line through it? Do you guys agree with that? So all I'm going to do is just construct diagonal. My line maker tool is garbage, though. If we do it, it'd be nice. We're going to construct diagonal. Sorry. I can do it. Line maker tool can't do it, though. Okay, get rid of that. Let me see if, so I'm going to let's see if I can construct. So we're just going to, okay, we're just going to construct that, okay? It's pretty garbage, I'm sorry, but, all right, here we go. Now, Stephen, what are we doing there? Stephen, what are we doing? Okay, all right, that's cool. All right, so now, why can we say that? That's just a construction, right, guys? Between any 2 points, we can construct a segment. That's just a construction. Okay, we can take a straight edge and construct it. That's fine. Okay. All right. Now, what's the next move here? The next move is this. Oh, okay. Now, why is this? Now I can say this. Here's what I can say. Angle BAC is congruent to angle DCA. Why can I say that, class? Why can I say that, Sylvia? Alternate interior angles. Very good. So we can now say that these two angles are congruent. You guys see that? Good with that? Okay, so this is alternate interior angles. alternate interior angles. You guys follow me on that? Okay, now I think we can do another one, right? Can't we say, what can we say? We could say D angle DAC is congruent to angle BCA, right? See that? You guys with me on that? So now angle DAC is congruent to angle, what did I say? BCA. So those two are congruent. Why are those two congruent, ladies and gentlemen? Alternate interiors, because we also know that these two are parallel because it's a parallelogram. Okay, see that? So parallelograms are nice because we can get those two pairs of alternate interior angles in there. Okay, so this is alternate interior angles. You guys with me on that? Okay, now I'm kind of running out of room here. I'm going to come up here. Is that all right, guys? I'm just going to repeat this step here. If you want to number this, this is step 1, 2, 3, 4, 5. Okay, this is my statement reason again, and this is step 6. Okay, so now, can anyone see the next move? There's a move here. Grady, what's the move? Very good. Does everyone see that everyone see that AC is congruent to AC? Grady, why is AC congruent to AC? Reflexive property of congruence, right? So this is just the reflexive property. You guys with me on that? Okay. What's the next move here? Ben, what's the next move?
You can say that these two triangles
Oh, hold on, let me do this.
are congruent.
Okay.
I guess because of AAS.
Is it AAS or ASA? I think the side is between. It's ASA, right? Because the side is between the two angles, right? So now we can say they're congruent. So we can now say that triangle. Let's see here. We could say triangle BAC is congruent to triangle D. What did I do? I went BCA, right? Did I name that right? And that is why. That's why, guys. ASA. That's ASA. Okay, see that? Hey, what's up?
We're trying to find a fishing sticker, but we could only find this one
Yeah. So.
from Miss Williams.
Oh, awesome! Thank you.
Yeah.
That's meaningful. Excellent. I just got a sticker. All right, that's awesome. All right. It's a anchor. Okay. Hold on. Oh, here we go. Anchor. Isn't that cool? Yeah. I'm gonna put it on my water bottle right here. Okay. So after that, they're congruent. Now what can we say, class? Oh, well, actually, I think we can say all the things. Can we say all these sides are congruent, guys? We can say that AC is congruent to DC. Why, guys? CPCTC, right? I guess we can also say, because the triangles are congruent, so these two sides are congruent, right, guys? But we can also say that these two sides are congruent because the triangles are congruent. So now we can, I thought we had to break it down and just say it again, but I think we can now state that DA is congruent to CB, right? And why can we say that, guys? Again, CPCTC. So what we've proven, though, if you have a parallelogram, opposite sides parallel, opposite sides are also congruent. We good with that, guys? And that's a proof. Now, I'm not going to do the proof for all of these, but Ben kind of had a good intuition there. Yeah, congruent triangles is a big part of quadrilaterals, okay? Because a lot of times we can do diagonals with them. Okay, question, Kimberly. Step 8, let's see here. A, B, yeah, that's AB, sorry. Yep, not AC is a diagonal, right? So yeah, yep, AB. Is that good, guys? Yep, sorry about that. Can't believe I got one of my mistakes on film. That's never good. It's never good. Okay, don't post it on the internet. Okay, guys, see that? Any questions? Okay, so next one I want you to copy down. I don't think we need to do the proof on this. You guys okay if we just believe it on faith that there is a proof out there with congruent triangles? We could do it if we wanted to. All right, guys, so here we go.
Can we really just do the proof for us?
No. What's the difference, though?
Oh, there's no diagonal.
What? No, but what's it saying here? This is saying if it's a parallelogram, opposite angles are congruent. Oh, my goodness.
We did prove that with the other one though, because of CBCTC.
We could say this, yes. We could say that D is congruent to B, right? And then we would, how would we, but we have to prove A and C. We would have to switch the diagonal to do that, right?
Isn't it because, well, can you say that A angle is congruent to angle C because adding two congruent
Yeah.
angles together will make congruent angles?
Yeah, that's adding two congruent angles together. Yeah, I guess you probably could say that these two are congruent also because when you add two congruent angles together. So yeah, I guess we would just prove that. I think that's just a great proof. I think that takes care of everything. Guys, see that? So I don't think we need the proof anyways. So here we go, guys. If a quadrilateral is a parallelogram, then its opposite angles are congruent. Okay, so now we know that opposite angles of parallelograms are congruent. Not because it's the definition of a parallelogram, it's because we can prove that. And while you guys are writing this down, I'm going to put the anchor on my water bottle. Because no, not this one. This is going to be my first one.
I also have this. Guys, we need to bring Mr. Roden a whole bunch of stickers so we can fill up his water.
Do you want a police sticker? Union?
Not really. I'm not really a police union guy on my water bottle. I like more like fishing stuff. It's got to be fishing
Guys, we
themes.
need to overload Mr. Roden with fishing stickers.
Okay, I will show Miss Williams that. See, looks pretty nice, right? Pretty nice. Okay. Let's keep moving on. Are you guys, Riley? You can I move on, or you think, Ethan, you need a little time? Okay,
I need a little bit.
a little bit of time.
How are you, Mr. Roden?
I'm good. Feel free to fast forward this part if you're watching this online.
Go to 102 or 142.
Can I move? Okay, here's another one. This is a good one right here. Here, if it's a parallelogram, then the consecutive angles are supplementary. It means that these consecutive interior angles are supplementary. You guys remember, because really a parallelogram is just a bunch of transversals. Remember the transversal stuff, guys? If we went transversals like this, remember that these two are, what do we call those? Same side interior angles, right? What do we remember about same side interior angles, guys? They're supplementary. So we can say that all of these angles are supplementary. They all add up to a 180. Okay, see that? So these add up to 180. These add up to 180. And also these add up to 180. And these add up 180. So guys, and that's nice to know. So when you add the two angles, whether they're up and down or side to side, they are always going to be sup. What do the two angles say to each other? What are the two same side angles of a quadrilateral say to each other? Sup.
That's so funny.
No, I got to fix that a little bit because it's not just quadrilaterals. I would say, what do the same side interior angles of a parallelogram say to each other? Sup.
Did you not send this
Mr. Roden, that's so funny.
What?
I'm gonna see that on a comedy show.
Huh?
Did you send that joke to the joke committee?
This one, oh, of course. All my jokes are
Did you
proof.
practice that in the mirror?
Well, of course.
Did you laugh at yourself because it was so funny?
No, I don't laugh at my jokes.
Why not?
No, that's the beauty of dad jokes. They can't laugh.
Can't laugh at a dad joke. Yep.
I love my dad
Otherwise,
jokes.
I have a whole book of them I need to bring me. Okay.
do you not know the art of jokes? You should write a book of jokes.
All right, ladies and gentlemen, here's a biggie. Okay, diagonals of a parallelogram bisect each other. This is really important. So if you have two diagonals, guys, their diagonals are always going to bisect each other. So the diagonals, it doesn't say the diagonals are congruent to each other. It's not PS and PR are not always going to be congruent to each other in a basic slanty box, okay? But they are going to bisect each other. So QM and SM are going to be congruent, and PM and RM are going to be congruent. Okay. Now notice all those little chunks are not congruent to each other. It's just they bisect each other. So we get two pairs of congruent segments.
Wait, well, triangles that are opposite from each other.
Triangles that are opposite, yes, and then we could say all those, and that's how we would prove that. We would prove that by showing that these triangles are congruent to each other by using a lot of stuff, right? But I'm not going to do it. There's a lot of good stuff in there that we would prove. Okay, all right. So these are just kind of how many is this? These are the 4 huge theorems of slanty boxes, guys. Now, obviously, yes, we're going to be talking about rectangles, and obviously, yes, we're going to be talking about rhombi.
What about squares?
And when rhombuses and rectangles get married and love each other very much, and they have little babies, they call them, you know what they call them?
Mr.
Rhombitangles. Yeah, rhombitangles. Yeah, rhombitangle.
Are you sure it's not called a parallelogram?
No, a rectangle and a rhombus
How do you spell it?
make a rhombitangle, otherwise known as a square. Yep.
What?
Mr. Roden, that's not a word.
A square is a rhombitangle.
That's not a word.
Rhombitangle.
Oh, wait. I found something on check.com.
So,
It's a flashcard website, and it says that rectangle equals square.
yep, rhombitangle is a square. Yep. Okay,
So it's not a made-up word.
I made it up, but
No, it's not a real word.
okay.
Or at least Mr. Roden.
Let's call that good for today, and then we'll do some. Yep.